There are a few special forms when we are factoring that we just want to keep in mind when we are trying to factor these polynomials, and we're going to go over those today. But first, our joke: why do plants hate math? Because it gives them square roots. All right, so do you remember that when we multiplied our binomials and we had one that said a plus b and then the other one was a minus b, we called that the difference of our two squares. And so we knew that when we multiplied them out, we got rid of that middle term and it was just the a squared minus the b squared. Well, now we're going to just go the other way, just like we were. So we're going to be given this part first, and we're going to know that if we've got two perfect squares on both sides, so they have to be perfect squares, and it also has to be a minus sign. If it is a plus sign, then it is prime. It has to be that minus sign so that one of those factors can be plus, one can be minus, and that way they can be factored into that to get rid of that middle term. So remember, if it's a plus sign, it's going to be prime. If it's a minus sign, we're going to look and see if it's the difference of two squares. Okay, so let's just look at a few examples. So we have x squared minus 4. Well, x squared is a perfect square because it's x times x. 4 is also a perfect square. It is the perfect square of 2. It's 2 times 2. So we know that this is automatically going to factor into, well, x plus 2 and x minus 2. And these aren't too bad to, they're a little bit easier to recognize because they are just two terms. So two terms, both of those terms are perfect squares and a minus in the middle, okay? So here's another one, x squared minus 81. Two terms, perfect square, minus in the middle. Well, what's 81 a perfect square of? That is 9. 9 times 9 is 81. So we know that that's going to automatically factor into x plus 9, x minus 9. Okay, so let's look at a couple more examples. What if we have 36x squared minus 49? Well, 36 is a perfect square. So is x squared. And 49 is also perfect squares. So what are those perfect squares of? Well, 6 times 6 is 36, and 7 times 7 is 49. So let's think about how we would write that one. Would be 6x plus 7 and 6x minus 7. Okay, what about this one? 25x squared minus 1. Well, 25 is a perfect square. Well, what about 1? Is 1 a perfect square? Yes, it is. 1 is a perfect anything. So remember, 1 squared means 1 times 1, and 1 times 1 is just 1. So 1 is perfect all the way around. So that's going to be 5x plus 1 and 5x minus 1. So this one really and truly is one that you are going to see probably somewhere. But x squared minus 1, you're going to need to know that that factors to x plus 1, x minus 1. Because that perfect square of 1 is always sometimes confusing for people. Okay, what if we have, here's one more example, x squared plus 16. Well, we've got a perfect square, and we have another perfect square, but what's wrong with this one? It is a plus sign. It has to be a minus sign in order to factor this. So this one will be prime. Good job. I know you're all answering that already, so good job. Okay. First and foremost, especially in these, We always look for that GCF first. Okay, so again, anytime I'm given two terms, I'm automatically going to start thinking, are they the difference of two squares? Well, 18 is not a perfect square, nor is 2 a perfect square, but they do have a GCF. They've got some things in common. What term goes into both of those? Well, a 2 goes into both the 18 and the 2, and then we know from before that we always use the lowest exponent of our variable, and so that's 2x. So we're going to rewrite this as 2x, and if we take out the 2x out of 18, that gives us 9x squared. And we take the 2x out of the 2x, that gives us 1. But we need to always pay attention to what we have left. Can that be factored some more once I take that GCF out? Well, 9x squared minus 1 can be factored because this now becomes a perfect square. And 1 is also a perfect square, and it has a minus in the middle. So can you see what that would be factored as? And remember, you have to bring down that GCF as part of your answer. Okay, so what goes into both 72 and 18? Looks like 18 goes into both of those. So 72, well, let me see, here's GCF is 18. So 72 divided by 18 is 4 minus x squared. Now you may want your tendency to just go ahead and turn that around and say x squared minus 4, but that is not what that's saying. Remember, look at that. The 4 is positive. It's the x squared that's the negative. And because this is the difference of two squares, that's okay. We can just say 2 plus x and 2 minus x, because we're always looking to see, can we factor this thing some more? And that is the difference of two squares again. Okay, so here we've got another GCF. What have we got here? We have a 3 and an x. So let's take the 3x out. And that leaves us with 4x squared minus 1. Then we're going to look and see what's left and see if we can factor that some more. And yes, we can. That's 2x plus 1 and 2x minus 1. So again, perfect square, minus in the middle, check. So always sort of look for those. Well, what about this? We've got 81x to the 4th minus 16. Well, you might spend some time trying to figure out if there is a GCF there, but they're not. So remember, 81 is a perfect square. X to the 4th is a perfect square because it's x squared times x squared. Remember, we add those exponents, so honestly, any even number is a perfect square. And then 16 is also a perfect square, and we have the minus in the middle. So it's all perfect squares. So 81 is 9 squared. X to the 4th is x squared, and then 16 is 4. So that is going to factor 9x squared plus 4, 9x squared minus 4. So hopefully you're catching on to that. Here's one of those again that's in our book, but I don't expect you to memorize it. All I'm going to say here is that if I look at this and my first tendency is just going to be, oh, okay, well we have a 1 in front of that x squared. So I'm going to think, what times what is equal to 49? That adds up to be that 14. Well, that would be 7 times 7 is 49, and 7 plus 7 is 14. So those would factor to x plus 7 times x plus 7. Well, whenever I come up with the exact same binomials, it's just more proper, we'll say, to write it as x plus 7 squared, to write it like that, instead of x plus 7 times x plus 7. It's not wrong to write it this way. Like I said, it's just more Just looks better, I guess, in math to write it as that perfect squared. Sort of like using the word can't in an essay instead of saying cannot. So you might want to write cannot instead of can't because it just looks better and flows prettier. And that's the same thing with that in math. Okay, so let's look at this one. What times what's positive 9 that adds up to be a negative 6? Well, you can think about that for a little while, but it's x minus 3 times x minus 3. Well, the proper way to write that would be x minus 3 squared. Okay, so what about this one? 16x squared minus 56x plus 49. Well, you could use big X method on here, and you're going to get some really big numbers, which is okay. 16 times 49, ooh, 784, and then we have negative 56. Well, you're going to have to sit here and think about all these factors of 784 that add up to be a negative 56, but I'm going to notice that these are both perfect squares, so I'm going to just check and see, would that 4x minus 7, see how I get the 4, that's a perfect square, and the 7 right here. Let's just see if this multiplies out to be what we would need to check this. That might be faster than coming up with all of these. 4 times the 4x's are 16x squared. 4x times 7 is your negative 28x, and then we have negative 7 times the 4, so negative 28x, and then plus 49. So we've come up with the 16 and the 49, but is 28 and 28, or negative 28 plus a negative 28, negative 56? Yes, it is. So we checked our answer maybe quicker than what we could come up with all those factors. And we're just going to write it correctly as a perfect square, if you notice that. Okay, so again here, you could use big X on this. 4 times 9 is 36. That adds up to be 12. We're going to go back and divide by 4. So what times what's 36 that adds up to be 12? Well, 6 and 6. Well, if we reduce those, we get 3 over 2 on both sides. So that is bottom number moves to the front of my binomial. Don't forget to put that y on the end. So we get this on both sides. And then the proper way to write that would be as a perfect square. So those can work nice, and there's are your formulas if you want to memorize them. You don't have to. I would just say factor them in the way that always works, and then if you just happen to end up with the same binomials, write it as a perfect square. And that's it for the special forms.